Hello friends, welcome to Practical Estimation and Costing Training Program. Today's session on RCC Stub Column Quantity Takeoff. Today we learn setting up the Excel format for stub column quantity takeoff, quick walkthrough of key data entry points. My next video on convert the Excel format of stub column quantity to a typical floor column and perform the quantity takeoff in 5 minutes. Stay tuned for more efficient and quick technique in our upcoming sessions. Please like, share and subscribe to the channel. Please complete this exercise and mold the Excel format to your specifications or in accordance with the consultant's drawing. This task is a one-time endeavor throughout your entire professional career. This is the Excel format. This is the notes regarding work out the quantity takeoff of stub column. Steel grade Fe500D, grade of concrete M50, drawing name, cover 40 mm, given on consultant drawing, lap length also same, stub column height. Stub column height is 2.2 meter, grade slab, finished plinth level and putting PCC top. This is a 2.2 meter. This format we have to work out concrete reinforcement and shuttering. For stub column, for reinforcement height is 2.2 meter, grade slab level 2, footing PCC top. For concrete work, excluding footing depth. Here is the concrete. Now we set the format according to this drawing. This is a stub column format, serial number, grade of concrete, description, number of column, width, breadth, spacing, quantity of concrete, number of bar, horizontal length, vertical length, bend. Uh, if you have expert, please club all these three columns in single format. This is a total length of bar, diameter of bar, weight per running meter, diameter of bar. This quantity we have to work out on if formula. We have seen this on previous video, RCC footing quantity takeoff, and here is the shuttering. Now serial number 1, grade of concrete M50, column number C35, steel height is 2.2 meter, footing depth we have to consider here 1.2 meter, column concrete height is total steel height minus footing, 1 meter. This is the column details. Size of column is 1 meter by 1 meter. Now multiply this and column concrete height. We get it quantity of column concrete quantity. Main bar, 24 numbers of bar and 25 mm diameter. Number of bar 24, diameter of bar 25. We have complete these two fields. First of main stirrup 8 mm dia, 150 mm spacing. We use here a round up formula for numbers of main stirrups. ROUND, round up stub column height divided by spacing 150 mm. For that, comma 0. Same for secondary stirrups, square shape. Here is the 1, 2, 3, 4. 4 numbers of secondary stirrups in square shapes. Control D, give the length 2.2 multiplied by 4. Secondary stirrups, triangular shapes. 1, 2, 3, 4, 5, 6, 7, 8. Control D, set the formula, compute the height, 8 numbers. Diameter of bar is 8 mm. Now working on stirrups. Here is the 1 meter total length and deduct the cover of both sides. Cover is 40 mm. Minus 0.04 minus 0.04. Same copy here. Secondary stirrups in square. In secondary stirrups of square, how many partitions? 1, 2, 3, 4, 5. We get it this length without cover. Then this length divided by 5. Same copy here. Now triangular shapes. In triangular shapes, partitions, same 5 numbers. 1, 2, 3, 4, 5. Yes. We have count only this spacing. Divided by 5. Now we want to calculate this inclined length. The formula of inclined length is square root SQRT square root bracket in bracket multiply 2 times same value bracket complete plus second bracket other side bracket complete. We get it inclined length. Now calculate the length of main bar. Horizontal length is the 300.3. Vertical length is 2.2 minus cover 1 cover 0.04. If lap length is there plus in bracket 36 into diameter of bar 25 is all in mm divided by 1000. This is a vertical length. If lap length is not given on drawing or not required on site, then this is multiplied by 0. Enter. Automatically we get it the only vertical column length. This formula set for our typical floor also. That's why we have considered here lap length formula. And here is the bend deduction. Main bar is the 90 degree 2D, one number of bend and 2 into diameter of bar. Now going for main stirrups quantity. We have already worked out here the both sides quantity. we have here only multiply 2 horizontal side 2 plus one side anchor length 75 mm 0.075. Same, copy this formula, paste here, Control D for secondary square stirrups. Now for triangular stirrups, consider a horizontal length and one anchor. This is a horizontal length plus one anchor 0.075. Vertical side, consider this 0.08 plus inclined length plus one anchor 0.075. Now we set total length formula is horizontal length vertical length minus bend deduction. Same formula, drag here. Then we have to calculate the d square upon 162 kg per running meter weight of bar. Total weight is formula number of column, number of bar, total length and weight per running meter. Again drag this formula. Now we set the formula of if. How to set? If in bracket n column function F4 for fix the dollar, we only alphabet fix the dollar, not for numerics. Okay, same M30 equal to 6 comma total weight E3. Same function, press the function button and F4 and for fix the value of P alphabet. If not, then comma double semicolon double inverted comma dash again double inverted comma bracket complete, enter and drag the formula. Now for 8 mm, copy this, change 6, type 8, drag it, again replace 8 with 10, drag the formula. Similarly for all diameter. Now how to work out the quantity of shuttering? Simple, number of column, length, width, breadth and height of concrete. Here is the shuttering quantity. In bottom, total quantities for concrete, total weight of steel and diameter wise steel quantity and shuttering quantity in square meter. If you like, please like, share and subscribe to the channel. Thank you very much.